So my name is Jirika Kresmer. I work for Red Hat on a team called regionalytics.io, and I'll be talking in the next 15 minutes about Spark Operators and also a little bit about operators in general. Yeah, so here's a brief outline. I'm reusing this presentation from a different presentation I've already done. Hopefully it will be still relevant to our topic. So yeah, I'll describe what the operator pattern is, then describe the pros and cons between choosing configured maps or custom resources. Then I will compare two existing Spark operators. And yeah, let's do that. So I'm using this notation operator of X, where X means the system operator is managing. So in a way, it's a feature that extends Kubernetes core features, because Kubernetes is kind of mature these days, and operators is a way to extend it for your custom use case. Most of the time is used for deploying custom systems like Spark or others. It's a Kubernetes native application, meaning that it doesn't actually make any sense without Kubernetes because it's calling the Kubernetes APIs. It's an event-based system. It reacts on various events when those resources are created, updated, or deleted. And before, I think it was called also controllers. If you ever hit the name. There is a very simple example, because at the end it's a machine learning special interest group, so people don't know about operators. So at first, operator has to register itself. It has to say the Kubernetes API, hey, I'm here, I'm listening for custom resources of type X. Okay, Kubernetes server registered the request. Okay, and after some time, if there is a new resource, in the Kubernetes server, it notifies the operator, and now it's a responsibility of the operator to do something about it. So in our example, it starts to think, and after some hopefully short time, it will respond with some action. In our case, it's deploying the system X in N replicas, where the N could have been described in the resource representing the system X. Very high level description. And again, after some time, someone could have deleted that resource in the Kubernetes, and it's again responsibility of the operator to clean all the resources that were connected with the system X. So either pods, services, routes, replication controller, whatever it previously created, it should now clean. So in other words, it's managing the life cycle of system X in Kubernetes. That's what operators should do. In comparison to something you may have heard about, for instance, OpenShift templates are similar in a way that it's also a deployment mechanism. Helm charts also it's the deployment mechanism, customizer or KSONet. But these are more tools that can operate with those YAMLs. Each tool has different strategy for the task. But in comparison with operators are more real-time based systems that are actually reacting on the fly on those events. And they are also part of the Kubernetes itself. Handy agents that can do handy stuff. So what I mean by representation of X. Normally these days it's a custom resource, because it's a way how you can extend Kubernetes for your own resources. So first you have to create custom resource definition, and then you're allowed to create resources of the type. So custom resource definition is a type, and custom resource is an instance of the type. But you can also use config maps for this use case. It's not originally my idea. I think Stringy was the first operator that have used it, Kafka operator, and it's a lightweight approach that can work in OpenShift environment, because you don't need cluster admin rights for this task. So here is an example of custom resource definition, custom resource particularly for Spark operator. As you can see under the spec section, you can have something like number of replicas for workers, number of replicas for masters, some custom Spark configuration that can override the defaults of Spark, and pretty much arbitrary information, but you also have to handle it in the operator and do something with it. And here is an example of the same, but using config map. So I can switch a couple of times back and forth, and you can spot that it's pretty much the same thing. The only difference is that the config maps, I had to use the config section and the value with a multi-line value that actually contains the deep configuration, because by default config maps are kind of flat structure containing key and values. Right, so some pros and cons. I already mentioned some, but for instance, with CRDs, there is a much finer grade RBAC, so you can specify which user's account is capable of what tasks. And for instance, also the API is slightly nicer because you can write kubectl or OC get and then directly the name of the custom resource. But in case of config maps, you have to put this config map before the X. But it's a slightly, just a little minor difference. So let's talk about Spark Operator. Just a couple of words about Spark. It's a unified analytic engine, mostly used these days for ETL tasks, but it also has libraries for machine learning, also for graph processing and streaming. And also there is also module for where you can use SQL-like language for manipulating tons of data in parallel. So Spark operators can deploy Spark clusters and also so-called intelligent applications that itself spawns its own Spark clusters. These are different two basic strategies, and I'm going to talk about two different operators, from which the first one is from GCP, Google Cloud Platform, and does the second task. It deploys the Spark applications that are capable of deploying Spark clusters using Kubernetes as a scheduling mechanism. So speaking very low level, it does Spark submit and uses this K8s as a protocol for Spark master. And there was a feature introduced in Spark 2.3 that can understand this protocol, and you are also you can also provide like custom images for these Spark submit tasks, and it should create a pods with client that itself spawns a driver, and a driver spawns an executors. But this is all handled by the Spark itself, implemented directly in Spark. So what the operator does, it creates these kind of applications, and it's meant for batch processing. But the GCP operator also contains something called scheduled application, where you can use cron-like expressions, where you can describe, for instance, I don't know, each hour at midnight or each midnight run some tasks, for instance, you know, those batch processing that happens in a bank during night. It's written in Go language, and yeah, that's the GCP operator. And I've also created one operator that's living in this repository, redanalytics.io Spark operator, and it does both. It deploys Spark clusters and also those Spark applications that can itself deploy Spark clusters. So what's the difference between when I say like it can deploy Spark clusters? The difference is that it's not that the lifecycle of the cluster is not bound to the lifecycle of the application, because there is basically no application. You can create Spark clusters, and then you can create, for instance, notebook instance, Jupyter notebook that can connect to the Spark cluster. It doesn't necessarily has to use this new feature in Spark that can use Kubernetes as a scheduling mechanism. The huge difference is written in Java. It's Kubernetes native. By that I mean that it doesn't use any OpenShift specific APIs, so it runs on Kubernetes and on OpenShift. And yeah, the part that's responsible for spawning a Spark application is actually compatible with the first operator. I'm using the same names for the fields in the configuration to avoid vendor lock-in, and ideally user could use the same custom resources for both operators. But currently I'm supporting only a subset of those options. Right, so let's do a demo. And this is, by the way, my attempt to create transition from Spark logo to Kubernetes logo. So first I need to run my cluster up. I'm using some old version of OpenShift, but it's faster to use this version than the new one. So bear with me. I guess I'm running out of time, so I'll be quick. So now I have the cluster up. I can create the operator itself. I'm actually querying the external URL. I can check what's there. So this is the manifest that deploys the operator. It has a couple of stuff like service account, a role binding, and deployment of the operator itself. I run that and watch for the pods. That it's creating a container, and within 2 seconds or 3 seconds, it's there. And now there's an operator watching on config maps by default. So I can create a new config map of a given type or a given label. And if I do that, it should start deploying the cluster for me. So let's use this one and show how it looks like actually. It's a config map, and this is the label that should be here, and it's like it's something that tries to like provide some type for the config maps, not to watch on all config maps, but only on those with these labels. So by now it should be deployed. Yeah, so the cluster is running for 20 seconds, and I should start using the cluster from either notebook or anything what I want for my custom analysis. Once I've done my work, I can also delete the cluster. So if I now delete the custom resource, config map that represents this cluster, the cluster should be gone. Yeah, it's terminating. Oh, and what is, by the way, the watch OC get pods. All right, so this was the example for the clusters, and I've got also example for the applications. So I can also create app, and these apps look like this. So there is a different kind called app, and it says deploy this image, and on that image, this file should be present, and run it as a Java application, and run actually this main class. It's a Spark examples is present in each Spark distribution. It's like main application used for hello world purposes. So what it does right now, it uses the different approach. So also again watching the pods, running pods, it spawns this is the client, which itself created a driver, and the driver will be creating shortly the executor that does the right actual work. And if I will be watching logs of the driver, I should be able to see that it will submits the application and got the results. But I think it should run for minutes or two. So if I'm out of time, I'm okay to finish right here. And I think this is a different point to mention, because these days everyone assumes that Go is the right language for writing the operators. I won't disagree. I think Go is perfect language for doing that because it's statically typed and it produces very small images. But I would argue that there is also a different topic or a different angle to see that. It's also the domain expertise. Like if the system X is written in language Y, maybe handy to preserve the knowledge with the same language. So for instance, Spark is written in Java/Scala. it may be good to use the same language for writing the operator for the system, because you may find the experts from the system X also to contribute to the operator. Yes, that was my point. And thank you for listening and watching. Yeah.
Awesome. I also invited Sharon Yu, who is from Lightbend, who is also interested in the Spark stuff, and we'd had a conversation about what Lightbend was doing. I'm wondering if Sharon, if you have anything to add to the Spark conversation and can give us a little bit of an insight into where Lightbend is going.
Yeah, sure. Thanks for the presentation. It was really nice. So at Lightbend, what we are planning to do is we are going to integrate the GCP Spark Operator into our Lightbend offering. So I have a few questions regarding the Spark Operator that you built. So if my understanding is correct, so basically it's adding your operator is adding a layer of indirection on top of the GCP operator, because there's a step to create the Spark cluster. Is that right?
No, it's sharing the description of the Spark application in order to be able to switch between those two. But I'm not using the GCP operator at all.
Yeah, no, I'm not implying that you're using the GCP operator, but like conceptually that so you are creating the Spark cluster, and then those pods are just running and staying there. And if you can, so if you launch a new Spark job, then they can just automatically use those resources.
Yeah, exactly. It's for long-living clusters that are not deleted once the application is stopped.
Okay. Yeah, but actually the GCP operator, I wouldn't say that it's used for batch applications, because you can also use it to launch streaming applications. As you said, it's basically just running Spark submit with a bunch of arguments. Yeah, you can run any kind of Spark job with Spark submit. So yeah. Yeah, cool. I'm also preparing a presentation just for the GCP Spark Operator. I'm gonna talk about a little more details, but yeah, I think what you said was pretty great. And I actually saw your Spark Operator a while ago, and I didn't take a closer look at it, but yeah, it looks interesting. I'll have to look at it again. Yeah, it's cool.
Thanks. I wanted to demo also the part that it's capable of working with custom resources, but I guess I was out of time.
Yeah.
There's a simple switch when deploying the operator. You specify CRD equals to true, and then instead of start watching on custom maps, config maps, it will start watching on CRDs. Okay.
And one more thing is that right now the GCP Spark Operator, for example, supports exporting Prometheus metrics for monitoring. Is that something that you are working on, or is it something that's already supported in your operator too?
Those images are enabled with metrics, so it should be pretty easy, but it's not there yet.
Okay. Yeah. Okay.
But the end Prometheus will scrape the metrics from the pods, so. I haven't tried it, to be honest, but it should be there actually. I haven't tried it.
Yeah. Right. Cool.
I mean, what do you mean Prometheus? Like, is that just for the pod itself? I mean, because the Spark itself. Where do you get the Spark itself from? Like upstream, or is it a Spark?
So, for example, for the GCP Spark Operator, there are two kinds of metrics that are exported. The first kind is as you said, the metrics that are already supported by Spark itself. All of those metrics exported in the Spark driver and the executor pods. Those are exported, and on top of that, there's a set of application level metrics. For example, what are the how many Spark jobs are currently running, and how many jobs have already completed? What are jobs that are still waiting to be started, that are to be scheduled, things like that. So higher level metrics.
And that's something that the Spark operator, the GCP Spark Operator exports?
Yeah.
Okay. Interesting.
Yeah. So then in my presentation, I'm gonna talk a little bit more about the GCP Spark Operator. But overall, it's very interesting, but also conceptually very simple. But that's what I like about it.
And with respect to the metrics, if I recall correctly, we had support for Jolokia. That's something that exposes JMX metrics from Java application as a REST service. And then Prometheus was able to scrape those metrics. I think there were two guys representing this idea on Spark Summit. I think they had set up with those images, like how to set up Prometheus next to Spark with our Spark images. But to be honest, I haven't tried it with Operator. So.
Thanks.
Hi, this is Guillaume speaking from Laval University. I have a small question for you. You mentioned very briefly Jupyter, and in our use case, what we want to do is, we are spinning Jupyter environments on demand for our researchers, and this is something that we discussed with Matt, I think, when we met at the last Red Hat Summit. We want to spawn Spark environment exactly at the same time and directly bind it to the Jupyter notebook. Initially, we had this approach we tried to make it work with Oshinko. Now that there are operators that are very close in terms of how it should work, which way do you think this would go? Is Oshinko going to be dead because everything goes down to operators, or what would be the path to take from now on?
I may be biased because I work mostly on Operator, but I think our strategy is to switch to Operator also from the Oshinko. So Oshinko in future versions should use these operators. So I would definitely go with Operator.
Okay, and in our use case, from the scripts that we use directly inside Jupyter Hub to spin the notebooks directly in their own pods, we could call directly the operators to spin the Spark environment at the same time and do all the bindings and everything. Should it work like this?
Yeah, it should definitely work. And there's actually a team in Red Hat that does the pretty same thing. They call it Open Data Hub, and they use this operator and they create config maps for creating new Spark clusters. And they've got Jupyter Hub in the system, and they connect those two together. But it's definitely doable. It should work. I had idea to also add notebooks in the operator, but I didn't want to complicate the operator with kind of irrelevant stuff, because I like the idea that it does one thing well, rather than if I do that, like which notebook should be the right one? Zeppelin, Jupyter, Spark notebook. There are multiple vendors. In ideal world, you could have operator also for Jupyter, and those operators could fit into those open operator lifecycle management tool that's developed in Red Hat, like meta operator of operators, where you can describe that your operator requires other custom resources. So you can kind of assume that the Spark operator would require other operators for handling the Jupyter notebooks, or creating a higher level one that will require those two lower level ones.
Okay, thank you.
Are there any other comments or questions on the Spark operators? And thanks again, Jirka, for coming in at 6 p.m. In your time. You're based in Brno, I believe, in the Czech Republic. So, hey, thank you.
No problem. Thanks for having me here.